So you are welcome, ladies and gentlemen, to this lecture for today. This data set, and please listen, this data set, we are going to use it for a number of things, and I mean a number of things, interesting things. We are going to use this data set to estimate the technical productivity, and we are also going to use it to estimate the cost productivity. Can somebody tell me the difference between the technical productivity and the cost productivity? Who can tell us the difference between the technical productivity and the cost productivity? Who has an idea to tell us the difference? Anybody? Any strong person? Technical or cost productivity? Thelma, can you tell us the difference?
Doc, one is to increase output over time, just output over time, and cost is to increase output over time whilst minimizing cost.
Okay, you've tried wrongly. Yes, come again. What is the difference between technical productivity and the cost productivity? Nathaniel. Yes, Nathaniel. Yes, Elikule.
Please, I think that with the technical productivity, it doesn't use the input prices, but the cost productivity considers the input prices.
Exactly. So whilst both of them use input and output, the technical productivity deals with just the input and output without input prices. Now, if we are estimating with input prices, then we have cost productivity. Now, if we are estimating with both input prices and output prices, what do we have? Both input prices and output prices, what do we have? Emmanuel.
Look,
Yes, Dinah.
profits productivity.
Okay. Now, if we estimate it with input and output, but output prices, what do we have? Joyce.
Doc, that would be. Oh, sorry.
What do we have, Joyce? Savior. What would you have if you have output prices? Thelma. Thelma.
Doc, please, I don't know.
Yao.
I don't know, Doc.
Okay. Dinah, tell them.
Doc, that would be revenue. Revenue productivity.
Good. And the revenue productivity. Revenue productivity. So keep these things in mind. If you don't know, you are learning. All right. So we are going to estimate technical productivity with this data. We are also going to estimate cost productivity with this data. Now, please listen carefully. The technical productivity, we are going to estimate it under both VRS and CRS. However, because we have normalized the output into 1, 1, 1, the score will be the same for VRS and CRS. So we'll just estimate it under CRS. But the cost productivity that was developed was only under CRS. So please take note. All right. So let's assume that we are going to scatter plot this data. That we have this whole thing. These are the outputs, the picture output of the data. You can see from here that we have the DMUs in year 1. That is why you have 0, 0, 0. DMUs in year zeros. Okay. And then you can see that we've drawn the radial lines, and we've also estimated the marginal cost. The marginal cost. How we got the marginal cost line drawn the way it is, we got to know all of this the last time. Now let's box on. Then we also include the year 2 data or the year 1 data. Let's focus on year 0 and year 1. So if you look at the year 1 data, it is a red frontier. It is a red frontier. And then the year 0 data, it is the blue frontier. This is how you would have normally estimated technical productivity. So this graph you're seeing on your screen doesn't include the cost. If we are to estimate the technical productivity for one of the DMUs, how would we go about it? It's a very simple thing. This is just a recap. But I'm doing this recap for a reason. Now, I'm going to use the distance functions throughout. I want to repeat. I'll be using distance functions throughout. Now, distance function is the opposite of what? Who can tell me?
Technical efficiency.
Is the opposite of what?
Technical efficiency.
Okay, so you see, next time somebody is also going to say the same answer. All of you say the same thing. Okay. So technical efficiency, it is not the same as technical efficiency. It is the reciprocal of technical efficiency. It is the reciprocal of technical efficiency. So who can define the technical efficiency, the calculation? How do we calculate it? Distance to what over distance to what? Who remembers? Who remembers? Distance to what? L12.
Please, technical efficiency is distance to frontier over distance to the firm.
Okay, L12, stay there. So what will be distance function?
It will be the reciprocal, which is distance to the firm over distance to the frontier.
Repeat.
It will be the reciprocal, which is distance to the firm over distance to the frontier.
Good. So I want you all to write that in your notebook and keep that in your mind as we start. So we are going to be dealing with distance to the firm over distance to the frontier, instead of the technical efficiency, which is the distance to the frontier over distance to the firm. Keep that in mind. Okay, keep that in mind a lot because this is important. So this is it. So let's deal with firm E. E. If you look at firm E, we are going to calculate the distance function for E0. Distance function for E0, which is in year T. Okay, what will it be? Who can take a guess and tell me what over what will it be? Don't use the numbers here. Use the letters that are in the table. It will be what over what? Yes, who can raise a hand and tell me? It will be what divided by what? For if you are calculating the distance function for E0, what will it be, Dinah? It is a radial measurement. So you start from the orange.
So it will be CO. Sorry, it will be EO over CO.
I think you should always bring the O first.
So
Don't say CO.
So
Oh, you are using the. Okay, it will be what?
distance to the firm, which is EO.
No, tell me all.
Over.
How will you calculate the distance function for EO?
Yeah, so it will be EO over CO.
Okay, but when you say EO, is meaningless. You have to, it's a radial measurement we are looking at. So you have to say OEO.
Oh, okay. Okay,
It's,
Doc.
it is 0 EO.
Okay.
That's how I want
Okay.
it. So
Okay,
start
Doc.
again.
Thank you. So that will be 0 EO over 0 CO.
Good.
Thank you.
EO over 0 CO. What would the value be?
That will be 7.5 over 5.
Good. So that will be the distance function for EO, 7.5 over 5, which in technical efficiency terms, it will be what? Edwin.
Doc, I actually wanted to ask a question, but in technical efficiency to be 5 over 7.5.
All right, okay. So ask your question.
Yes, please. Please, is there a significance to using the distance function over the TE? I want to find out the reason why you are using the distance function.
Okay, so part of the reason why is that the model I'm going to be dealing with is it's a bit complex, and the authors wrote them in distance functions. So because they wrote them in distance function, I want to continue using them in distance functions, because that will make us do it faster. If I should convert all of them to efficiency, it will be a little bit tricky. So maybe later on, one of you will be happy to work that during your thesis, your bigger thesis that you'll be doing. But because the authors dealt with in distance function, that's why I want to maintain them in distance. Other than that, I am mostly all for technical efficiency. And also, the software we'll be using, the R software, is a distance function. It uses distance functions. You know the R software I'm talking about, the FEAR. Are you with me?
Yes.
So because the FEAR also uses that, I want to be dealing with using that as well.
Okay, Doc.
Does that answer your question?
Yes, please.
All right. So that is it. This is what you guys just said. Okay, 7.5 over 5, and that will give you 1.5. If it was technical efficiency, it would have been 0.667. That is just for you to know. You see, until you get that thing clear in your mind, you are going to just focus on one. And when you always see a paper that is using distance function, you might be confused. That is why I always also want you to understand the distance function approach. All right. So, if you look at it in terms of distance function, okay, if you were to estimate for E1, the distance function for E1, what would that be? You can raise a hand and walk us through that quickly as well. Because these are just petty things, but I want you to just understand it to the extent that you can teach it. What would be the distance function for E1? Anybody? If you were to calculate the distance function, okay.
Yes, so
What
that would be
period distance function? Yes.
for E1, that would be 0 E1 over 0 E1.
Exactly. Now, for your information, the value there is 2.1.
Okay.
Now, how do we know? Well, you can see that when you go to this number here. Okay. When you look at the bottom, you will see that they are all 2.1, 2.1. So the data will guide,
okay,
even if it's not obvious in the table. If you look at the table, if you don't take care, you might think that it's not obvious. Like this.
it is.
Unless you have a very bad eye. So 2.1 divided by 2.1 will give you what value?
1.
Okay, so what does that tell you about this firm E in year 1? I mean, in 0 year, and the same firm E in year 1. What does that tell you? Who can raise a hand and tell me this? What does that tell you? in terms of its performance, its efficiency.
Okay.
Xavier.
So in year one, the DMUE is technically efficient, but then in year 0, the DMUE is not technically efficient or is technically inefficient.
Good. So in year 0, it was inefficient. In year 1, it was efficient. Keep that in mind. So even though it's not looking good in year 0, it is looking better in year 1. After all, it's part of the firms that are determining the frontier. So keep that in mind. And note that the score that we've calculated, understand the score. Now, let's go quickly to the Malmquist estimation. If you can remember, the Malmquist is the product of 2 different Malmquist indices. According to Caves, Christensen, and Diewert, that was how we define the Malmquist. And if you want to define it in terms of distance function, this is how we know it. Now look at it. The value of the Malmquist, the right diagonals. If you look at the right diagonal, you have t at the bottom here. And then you have t plus I, t plus I, t plus I, or t plus 1, whichever one you want to look at it. You have t plus 1, t plus 1, t plus 1 on the top part. So the right diagonals, when the thing is moving like a supply curve from the bottom to the top, you can see that they are using the own period distance functions. Own period distance function. And then the cross period are from left to right, top to down. Okay, like a demand curve. So the demand curve are the cross period distance functions. And the supply curve are the own period distance function. Okay. So it's always important to know what is on top of what, and it's always important. And when you take the square root or geometric mean of that will give you the Malmquist. Now let's try to get that, estimate that from this table. So look at the first one here, the top one. I want you to understand. Okay. So what this means is that you are estimating the efficiency of a DMU in year 2, that is a t plus 1 or t plus I. In year 2, relative to the frontier t. Now go back to the graph and you see that frontier t is the blue one. Sorry, the frontier t is the blue one. That is the first frontier. And then the other frontier, okay, which is in this case the t plus I, is the red one. So you are estimating the efficiency of E, okay, E in year t plus 1. So E in year t plus 1 will be E1. That is this, E1, relative to the frontier in the other year, the previous year. Okay. And when you are estimating that, you will see that you are now estimating E1 relative to the blue frontier. And the radial line shows that it will be at the B0. And so remember the definition of distance function. It's a movement, and remember that the DMU is at the E1. So it is going to be OB0, which is a frontier, divided by OE1. OB0 divided by OE1. That is the distance to the frontier. Oh, I've defined it in terms of technical efficiency.
Technical.
So let's define it properly in terms of distance function. It will be distance to the firm. So OE1 over OEB0. Is that correct? Yeah. OE1 over OB0. It's very important to understand this. OE1 over OB0, where the E1 here is the firm. So that's what you see here. That is what you see at the top part here. So when you look at the top part here, you can see that we have OE1 over OB0. Okay. So that's the first part. Now, I'm doing the cross period because they are the confusing one. Now, when you look at the second one, okay, The one in the bracket at the bottom is the XTYT. So it is efficiency of the firm in 0 year relative to the frontier in 1. Okay. Or in this case, T plus I becomes the F1, the frontier 1. Not a frontier 0, but a frontier 1. Or if this one was frontier 1, not a frontier 2, not a frontier 1, but a frontier 2. Okay. It depends on which one you are dealing with. So you're going to estimate the efficiency of a firm in the current year relative to the frontier in the previous year. So this same thing, we are doing it for firm E. Who can walk us through that? Who can walk us through that? For the cross period, for the second cross period. So if you're going to do that one, yes, Chris.
Hello, Doc. Please, it will be. Sorry, please, it will be OE0 over OC1. So that will become 7.5 over 3.5.
So OE0 over OC1. So you're measuring C1 is in the second year, and then the E0 is in the previous year. And so
Yes,
it comes. And you are using distance function. So the distance to the firm over distance to the frontier. So that's correct. And that's exactly what you have here. Okay. That's exactly what you have right here. So you can use that approach, and then you can now be able to estimate the Malmquist productivity for firm E. For firm E. And when you do that, this is the value you get. You can go and check these things. I'm just showing you these things for the first one, but I want you to understand what is happening behind the scene. Because if you don't take care, if you don't understand what is happening behind the scene, you'll be confused. Now, so OE1 over OB1 is 2.1 over 3. That is a cross own period, and then this is the other own period. This was the one we had before, 2.1 over 2.1, 7.5 over 5, and then the cross period, the own period one is 7.5 over 3.5. Okay. Again, you can see that one here, OE0 over OC1, the one you just did. So this is what you have, and that will help you now to be able to now estimate that. The rest is calculator, 0.7 over 1.5 times 1 over 2.147. Take the square root of this, and that gives you a Malmquist, which is 0.467. 0.467. Now, remember, this is an input-oriented distance function. Input-oriented distance function. Input-oriented distance function. An input-oriented distance function, the value of the Malmquist is always implying that lower than 1 is progress, equal to 1 is constant, greater than 1 is regress. So here, this is progress. This is progress. The value 0.467 is progress. Now, if you want to know the actual progress, you take the reciprocal and do 1 divided by 0.467. Somebody should divide that and tell me the value.
Doc, please, you get 2.141.
Sorry?
Please, you get 2.141.
2.141.
Yes, please.
Do you know what that means? 2.14. Who can interpret that for us? Fem E. Who can interpret that? 2.141. How do you interpret that? Let me see if somebody has been listening. Chris.
Doc, please, it means that there's been a progress of 114%. The firm has progressed.
Say that again.
I'm saying that the firm has become more efficient by 114%. And 114%.
That is not a good interpretation. Who can interpret that 2.141 for us? You tried, but this wasn't the way it's supposed. Yes, Edwin.
For every one input that the firm used, it generated 2.141 more output.
Oh, no. You try, but you're far away from the promised land. Who can come again? Who can interpret 2.141 productivity score for us? L12.
Okay, please. I think that means that the firm E has progressed by 14.1%.
Firm E has progressed by
14.1%.
You came closer, but you are still not correct. You are the closest one so far, but that is still not correct. Who will come again? Nathaniel. After the corrections have been made, now finish it.
Means the firm progressed by 141%. There's been a 141% progress.
Oh,
41.
I thought you were going to correct it. It's 2.141. Oh, yeah. So the firm has increased productivity by 141%. Remember, Electrum, the answer you gave, you forgot to realize that we are not talking about anything above 2. We are talking about anything above 1.
Yes, please.
So the firm has increased productivity by 141%. That is what it means. There is a productivity progress of 141%. Yes, Chris, your hand is up.
Doc, please, with the percentage value, when you're supposed to subtract 1 from the reciprocal of the distance function, right?
Yes.
So when I did that, I got 114%. I got like 1.141. So when you multiply that by 100, you're supposed to get 114, not 141.
Yes.
Yes,
You got 140.
114.132.
That's why I was confused about his 141. It's supposed to be 114.
Yes, please.
Yeah. So initially I said he was wrong, but I don't know why I was. Maybe it sounded to me as 114, but it's supposed to be 114.1. Is that not so?
Yes, please. 114.132.
114.1%.
Yes, please.
I'm sure he also missed it. Okay. I'm sure he also...
Yes, please. I missed the
I'm
point and
sure
the
you
1.
missed it. I'm sure you missed it. So it's supposed to be 114.1%. So that has been the progress. So here's the point. DMU E in the first year, in the year 0, was inefficient. But in year 1, you can see that it is efficient. So, but you see, the good thing about dynamic productivity is that it helps you to know the extent to which it has changed. Now, if you look at it carefully, you might not appreciate a lot compared to somebody who was efficient. For example, you can have a firm like, let's just go up here. Okay. If you look at a firm like, have you seen DMUC?
Yes, please.
DMUC was efficient in year 0. It was also efficient in year 1. So you might think that DMUC is always among the top class guys. But the question is whether it has changed. Its question is whether it has increased productivity. And maybe when you go and calculate it, and by the way, we shall calculate it, okay? Maybe when you go and calculate it, you come to realize that there hasn't been productivity change at all for that firm, even though it's looking efficient in both angles. Okay? So sometimes a person can be looking good because that person he's okay because his peers he's dealing with are not good themselves. Have you seen that thing before?
Yes, please.
Like a person can go to a particular university and he's a top guy. He's a top guy. So he's forgetting that he has potential to improve. He has the potential, but nobody is challenging him, and so the guy is he's looking like Jata. The guy is not moving, and he keeps boasting that he's the best guy. He's the best guy, and then one day you moved him from that university, and then he goes to do his masters in another university, and all of a sudden he's the last. Okay, so it means that he has not been improving. But then there could be this guy in the first university. Okay, he's not looking good, so he pushes himself. He pushes himself, and then when they go, because he has learned how to push himself, he now goes to another university, and now he knows how to push himself. So he pushes himself further, and then he becomes among the creme de la cremes. So here is a point: the essence of dynamic trends. It helps you to know the progression. So a firm might not be looking good presently, but over time, the firm is showing clear evidence of progression. And we like that because everything is in continuum, more or less. We grow over time. We get money over time. We marry over time. We school over time. We do everything over time. So it's good to get dynamic trends. Okay. So keep that in mind, that DMU E is doing great. It's doing great in this very contest. All right. Now, this is the firm. We can now decompose where the source of the productivity is for DME. The essence of the Malmquist decomposition is just to find out where or which one is doing well. I mean, what is driving the productivity? Is it productivity due to your own doing? That's the first part here. So the first part here is called efficiency change. Sometimes the name we give to it is catching up to the frontier. That is why you can see that everything is in the own period. So this is all in the own period. Okay, the second year period, and then this one is the first year period. So this is like year 0, and the top one is like year 1. So what this one does is this efficiency change. What it does is that it is capturing performance from your own knowledge, efficiency due to managerial acumen. And this is true because a person can do well because he is pushing himself, or it is possible that a person is doing well because the university itself is doing well. The university itself is pushing people to do well, so the person has no chance but to leverage on the technological spillovers, which is the second part here. So the second part is talking about technological change or technical change. We are going to calculate that for DMU E, but please remember that if you look at the information we are having now, look at the information we are having now. Okay, the values you had, the values you used, okay, to estimate the Malmquist are the same values, just that they are going to be rearranged. Okay, and so when you look at it carefully, I'm trying to use this thing. Let me just use some pen to do something. So when you look at this, these are 4 different distance functions. This is one, this is the other, this is the 4th one, and this is the 4th one. That's the 3rd one, this is the 4th. So you are using 4 different distance functions. We are going to use the same distance function, even though we are in the other section. So when we should go here, okay, when we should even go to the decomposed element, you are still going to see the same thing. It's the same thing, okay? The same different distance functions are what are shown here. It's just that they have been rearranged differently. So once you have those values, you will be able to just drop them. You know the value for t, dt, xt, yt. And then you know that. Are you guys with me?
Yes, sir.
Yes, please.
So using that, you can substitute and then you can get this score. And now watch the score. Okay. Of course, this manipulation, you should be able to know how to do it. And that gives you this. So the first part here gives you what? 0.667%. or approximately 0.7%. Okay, but I want us to use 0.67% for a reason. Okay, and then this is a technical change. Please know that the technical change is also called technological change. What does that mean? That one is the frontier shift. That's a technical name for it, the frontier shift. The frontier here is the technological frontier. So the frontier shift is indicating the performance as a result of the industry itself doing well. So if it is a student, the performance of the student, because the university, the class itself, they are good. And so the person is pushed to do well. But not that the person naturally is good, but that there's a kind of an external force. So the first part, the efficiency change, deals with internal reasons for productivity. Okay, latent internal reasons for product. And then this second part, the frontier shift or the technical change, deals with external reasons for productivity. Does that make sense? So a person can do well because the parents are pushing him to do well. That's external. But a person is doing well because he himself want to do well. Does that make sense? He himself want to do well. So the DMU itself is doing well because there is management, corporate management is doing well. There's a lot of managerial acumen, skills, experience are all operative. These terminologies, these words, sometimes when you're looking for them to write your thesis, you don't get them. That's why I'm giving them to you. Okay, that words like experience, words like skill set, specialized managerial acumen, managerial skill set. Okay, that company themselves have. That is why the person is doing well, and that is 67% here, 0.67. And then the other one is the 0.7, which is the technical change. Okay, because there is some kind of technology, whether product or process innovation. Okay, there is some improvement in R&D, which is now helping that particular firms to do well. Okay, so this R&D that has been brought into the industry has generated a lot of technological spillovers, and of course the firm is capitalizing on the technological spillovers and then producing more or doing well. So all of them, if you convert each one of them to the reciprocal, of course these are all progress because the values are below 1. This is input productivity. Okay, so when you do that, you will now know what is driving the productivity. So take the reciprocal of each one. The efficiency change is what? And the technical change is what?
Please, for the efficiency change, it's 1.5.
1.5 for the efficiency. Okay.
Yes, please.
Now, the person who said 1.5, who was that?
It was Chris.
Chris. So Chris, what does that 1.5 mean?
The 1.5 means that DMUE has experienced, or 50% of the growth DMUE has experienced has been as a result of an improvement in the managerial acumen of the firm. Excellent.
So the firm experienced 50% efficiency progress. That's how you put it.
Okay, Doc.
Percent efficiency improvement. The word progress is the same as improvement. If it is regress, then it's going to be deterioration or decline. Okay, so you got some of the key words. So the firm has experienced efficiency progress. There has been an improvement in efficiency, okay, by 50%. Excellent. What about the other one? The other one, Emma, is Emma Gbevivi. The other one is what? Yes, Nathaniel.
The other one is 1.429 or 1.43.
1.43. So what does
Yes.
that mean?
It means the firm progressed by 43% due to external factors.
Okay, so use the first term. So the first term, you call it what? Technological what?
Hello, come again, please. I didn't hear.
Progress of what? There's a technological progress by 40 what?
43%.
Good. So I want you to know that that word is technological progress or technical progress before you interpret it as there is an external, factor driving productivity, okay, by 43%. Yeah. So you see that 114%, 114%. Now, 114%, you can see that it's being driven by 50% progress from efficiency, and then 43% progress from what? From technology, from the technological dynamics. So you can see that. But of course, do you guys see that the entire progress is not due to all of this combined? Do you guys see that?
Yes.
Yes, Doc.
So what that means is that there is a possibility of some scale changes, okay, which have not been captured because this one is looking at only what? Only is looking at only efficiency change and technical change. Remember, there was a third component which we spoke about, which we call scale change. So maybe the scale change is driving the other aspect of it, which is not yet captured here. Or maybe it is decimals issues. Okay. Because technically, when you look at the numbers, without taking the reciprocal, the numbers add up to the original productivity score. So it's possible that it is it's possible that it has to do with decimals and numerical computations. Okay. Not necessarily in that format. All right. Any question on this for E? We are going to use this same firm E to estimate its cost productivity. We have now been able to estimate the technical productivity of E. Now, when you use the max DA result, you are going to get the result all in a better way to interpret it easily. It looks like the thing is 114. Yeah, 114. Just as we agreed on. But the max DA software will handle it easily for you. The fear and the R will give you the score as I've given it to you here. So just know that. But the max DA software is simpler because it gives you the score in a way that is easily interpretable. So this is the interpretation. Input-oriented, okay, Malmquist productivity shows 114% progress from efficiency improvement, okay, of E, and then technological progress between year 0 and year 1. That is how you interpret it. Now let's go to the cost. Unless there's a question. Let's go to the cost. Unless there is a question. Unless there's a question. Any question?